computer mic. I'm going to assume you've read tonight's question. If not, go ahead and pause the video and either read it now or read your handout, because I'm just going to jump right into the answers. Black, anything I write in black is things you should write. And then when I'm writing in blue, blue is going to be just things, other notes, things that I'm saying to think out loud or to kind of remind you of what's kind of going on in the background of this question. And I'll try to do my best to stick to this color scheme. I'm sure it won't be perfect. Okay, first one we got to do is find g of 3. Always, anytime you have a function notation style question, it's a good idea just to literally write out the definition of g of 3 as the integral from -3 to 3, and then f of t dt. Doing that, just taking that little baby step of taking the function and plugging 3 in for x, doing something you learned years ago will often kind of get you off on the right foot. Because now, this is just integrate from -3 to 3 of f. So let's say we want to mark it off. Okay, from 3, -3 to 3. This is 3 by 4, so this is going to have a value of 6. This is 4 by 2, so this is going to have a value of 4, right? It's the area of a triangle. And then we have a little baby triangle right here that is 1 by 2. You can be confident that it's 2 because this is clearly a line that passes from y equals 0 to y equals -4 over the course of 2. So halfway is going to be y equal -2. And that is going to have an integral value of -1. Its area is 1, but it contributes as a negative to the integral's total. So we would say this is the integral from -3 to 3 equals 6 plus 4 minus 1 equals 9. And I would kind of consider that a model answer, right? You use the function notation, you show on the graph what you're trying to measure, and then you use those values to come up with the total for g of 3's value. Question B is a fundamental theorem of calculus part 1 question. This is where I want to remind you guys, and I'm putting this in black, even though it's probably not part of what they grade. Every time we see this style function, I want you to put equals and then whatever this is, so equals g prime. Once again, this little baby step, much like this baby step, is going to make the whole problem easier. Now what the rest of the question is going to do is just review those things we learned back in November about a function is increasing when its derivative is positive, or a function is concave up when its second derivative is negative. Okay, we're going to go to the blue notes. I'm going to write down kind of the basic thoughts, and then we're going to consolidate them into an answer over here in black. G increasing. Okay, G increasing means G prime positive. But since we have this helpful little note, that's kind of the same as saying F positive. And then we have concave down also. We've done increasing. Concave down, G is, we'll call it CD. So concavity is based on the second derivative. Concave down is going to be G prime negative. But if G prime is F, G double prime, that's like down a layer. And if you haven't watched the movie Inception yet, you still need to watch the movie Inception. I'm not kidding when I say it's required for this course. That's F prime negative. Okay, so this is kind of the idea behind this problem. Step 1, we're going to apply FTOC part 1. And applying it really just means adding this labeling system. And then we're going to use some just basic relationships we learned towards the beginning of the course. All right, let's do our student answer. So, hold on, we actually got, let's figure this. When is F positive? F positive, let's see here. This is all F positive. This is F, so this is all F positive, so this is all G prime positive, so this is all G increasing. F prime negative, well, that's just another way of saying F decreasing. So we need the positive sections of the graph where it's decreasing. All right, here we are positive but decreasing. Here we are positive but decreasing. So that's what we're going to use as our answer. And I'm going to clear that space away because I might want it for later. So let's go to our student answer. We are going to say it is from, and I like to use inequality notation. So I'm going to say -5 less than or equal to x less than or equal to negative 3. And we're going to say from 0 less than or equal to x less than or equal to 2. And we need a reason for your answer. Here's where we're going to kind of put all this to work, and here's how I'd like us to write it. Our reasons are going to be, and honestly, we don't have to write a long sentence. Let's just stick to the order. Let's do increasing first. Our reason is because g prime, which is equal to f, is positive, and g double prime, which is equal to f prime, is negative. And I think that would be sufficient, but we're trying to kind of go all the way, so we're going to say because f is decreasing. Here's why we added that little bit. This is a picture of f. So even though technically, like, this is the reason, we got to talk about something on f that fits this. So this is the reason, but how do we see this? We see f decreasing as a way of seeing this g double prime equal f prime negative. So that's kind of a nice complete solution, right? We have our basic principles, we identified our domain, and then we kind of wrote a comprehensive reason. We got our g prime, which is f, and that's positive, right? F positive, so we're referencing the graph of f. And then g double prime, which is f prime, that's negative. And how do we know that's negative? Let's reference this graph again, because this graph is decreasing. All right, I think that's pretty good. What I'm going to do is clear the space and redraw the workspace over here. You'll see what I mean before we do C and D. Okay, let's add some of our kind of space to work with back over here. Oops. Draw that on there. Okay. C. Listen. Don't ever, hey, fraction, we got a fraction and we got a derivative. So you should think quotient rule, right? C is going to be quotient rule, so we got low d high minus high d low over low low. So let's go ahead and put that to work. First, we're going to identify h prime of x. H prime of x, let's see here, we need low d high. So low is f of x. And then d high, let's just call d high g prime of x. Let's not worry too much about what to do with that yet. Let's just stick to the basics of the quotient rule. Now we need high d low. High is g of x. And d low, the derivative of 5x is 5. Now we need some low low. So please do not write that. Write that. If you wanted to simplify this to 25x squared, that's okay. But honestly, I don't think we need to. Anytime our goal is to produce a number, simplifying the expressions usually doesn't matter too much. So I tell you what, let's just kind of leave this the way it is, and let's plug 3 in. In goes our 3, and let's see what happens. We have 5 times 3. We have g prime of 3. We have g of 3. And we have 5. Sorry, I ran out of room there. And then down here, oh, well, we have 5 times 3 squared, right? So that's a number. So whether or not we simplified it up here is not, you know, you can, but it's not helping you any. It's just going to be 15 squared. You do actually have to know what 15 squared is, even though this is no calculator allowed. But 15 squared is 25. And if you don't, you know, you don't remember that, count out 15 15s and see what you get. Okay, let's get to work. Don't know, sorry about this little line right here. Obviously got a little overzealous with the size. 5 times 3 is 15. G prime of 3. This is where this is going to be so helpful. Hey, what's f of 3? F of 3 is negative 2. We already learned that earlier. So this is 5 times 3 times negative 2. This is negative 30. Minus, and now we have g of 3. We already did that. G of 3 was 9 times 5. And then on our denominator here we have 225. And honestly, I think if you left it like this, you would probably get full credit. Let's at least kind of clean up the numerator and say that this is negative 30 minus 45. So it's negative 75 over 225. That fraction clearly reduces by dividing both terms by 5. And in fact, even dividing both terms by 25. But whether you do that doesn't really matter. You're going to get the points because you knew the quotient rule. You use the correct values for things like g prime of 3 and g of 3. And you have a numerical amount that is correct. We have one question left, which is question D. Let's knock that one out. Once again, I'm going to clean out my workspace and redraw it so it looks a little prettier. Oops, made the same mistake. Got a little bit. There we go. So this is a tangent line problem, or it's really just find the slope of the tangent line to the graph of P. So in other words, we are going to take this question and we are going to simplify it to the following. This is for D. Find P prime of negative 1. That's all we care about, right? The slope of the line tangent at negative 1 is basically just saying, hey, what is the rate of change at negative 1? Or what is P prime's derivative at negative 1? Okay, so let's go about this. Much like this was really just quotient rule. If you freaked out because you saw g of x and you didn't just start with basic quotient rule, hopefully you saw that it's really best just to kind of get started. Same thing here. This is going to be basic chain rule. Don't worry too much about that it's like f of something. Just kind of think, okay, I'm going to do chain rule and see how it goes. So we need P prime of x. So how the chain rule works is you do the outside layer first. Hey, the outside layer is f. You know what the derivative of f is? F prime. F prime, and then your something. The derivative of f of something is f prime of something. And then hopefully you've already finished this sentence in your head, times something prime, times 2x minus 1. Right? Outside layer prime, then chain on inside layer prime, or derivative of the inside layer. Once again, like we could simplify this, but look, if our goal is a value, let's just plug in negative 1 and let that do the work. We have f prime of negative 1 squared minus negative 1 times 2 times negative 1 minus 1. All right, let me make sure I have this right. This is going to be f prime. This is 1 plus 1, f prime of 2. And then this is going to be times, I think this is negative 3. I hope so. So what we really just need to know is what is f prime of 2? Well, let's look at our graph. What's the slope at 2? What's f prime of 2? It seems to be negative 2. I think we can agree this is a slope of negative 2. It's kind of pretty obvious that it's down 4 and over 2. So in other words, it's down 2 and over 1. So this is negative 2 times negative 3. This is negative 6. By the way, this is kind of what I would expect in a student answer. Anything I wrote in black in this video is pretty much things you should be writing. By the way, hey, this little label, that right there was the key to almost everything in this problem except g of 3, which was just do the areas, and that was pretty straightforward. That's why I'm always emphasizing, please, just step 1, add that little thing automatically. It's always going to play an important role. Let me make sure I feel good about this answer. I think I do. We did our chain rule. F prime of something times something prime. We plugged in negative 1. These values seem correct. And then our f prime of 2 seems correct. Right? You wouldn't get penalized, but those should be in parentheses. Negative 6. All right. I hope this explained anything with the homework. I hope your answers were correct. I hope this was helpful. Make sure you're doing these for each night, especially if you're struggling or if you have the time.